resistors of 4 ohm are connected in parallel. Which of the following, whenever two resistors are in parallel, the combined resistance, if you want to find the combined resistance, the formula is the product divided by sum. So 4 multiplied by 4 divided by 4 plus 4. So it will be 16 divided by 8, which is equals to 2 ohm. But remember, this formula is only valid for 2. The product divided by sum is valid for 2. If there were 3, then I will use the expression 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Question 2, this is a displacement and time graph is there for a water waves. Which property cannot be determined using the information? So amplitude, I can determine the amplitude, I can measure the vertical height, I'll get the amplitude. I can determine, because x-axis is the time period, so time to complete one vibration, I'll get the time period. And from time period, I can work out the frequency. Frequency is reciprocal of the time period. So we can work out amplitude, frequency, time period, but wavelength we cannot determine. Why? Because the horizontal distance, this is not the wavelength. Why it is not a wavelength? Because x-axis is the time axis. If it was a distance axis, then I can work out the wavelength. With the time axis, I cannot work out the wavelength. That's why wavelength cannot be determined from this information. Student measure and record 4 values of a length. Which of the following should be recorded as a mean? Remember, whenever you have a set or a group of values, for anomalous result, wrong result, you have to ignore. Like 50.2, 49.9, 49.4 appear to be in the same order, but this 41.1 appear to be an error. So we have to neglect. So when we are taking an average, we'll add only these 3 values. So it will be 50.2, 49.9 and 49.4 and divided by 3. So it will give us 49.8. In question 4, during a scan of an unborn baby, a series of ultrasound pulses are transmitted through a mother body and the reflected pulses are detected. The duration of each ultrasound pulse is kept as small as possible. What is the reason for that? When we use a small pulse, so we'll get more detailed image. Like if the pulse is shorter, then because normally what happens when the pulse completed its cycle, part of the pulse is reflected. So when we keep the shorter pulse, what we'll get more detailed image. So what is the advantage of using a shorter pulse? Enable more detail to be seen, because when pulse completed its cycle, part of the pulse bounce back. So we'll get more points within the object. That's why we'll get more detailed image. So this is related to pulse echo technique. A narrow beam of electron passes through a graphite, is then incident on a fluorescent screen. The pattern is observed. What this pattern shows, it shows that electron is, because if electron was a particle behaving like a particle, so we should get only one spot, or if it deviates, so 2 spots will be there, but not the pattern. This pattern is for diffraction. So, and diffraction is a property of a wave. So what it shows, which of the following conclusion about electron can be made from this? Electrons are being attracted, no, or scattered. The electrons are being diffracted by the graphite crystal, or we can also say electron is behaving like a wave. This confirms the wave particle duality, that particle can be a wave and wave can be a particle. In question 6, a lamp with input power of 500, the total surface area 2 meters square, the lamp has an efficiency of 30. Which of the following is a radiation on the surface? So if it is 30% efficient, we'll find how much power out is there on the surface. So efficiency is equals to useful power output, which we don't know, total power input multiplied by 100. So this 5 will be multiplied there, 6 multiplied by 3 multiplied by 5, so 150 watt will be the useful power. And now we need a flux. Flux is power per unit area. So 150 is the total power divided by 2. So which is equals to 75 watt per meter square. So for question 6, A should be the right answer. So the diagram shows two copper bars are there, M and N. So they are made up of same material, but they have different cross-sectional areas. Length is given. What about the area? Because if one side is X, this is also X. So this area will be X square. And this is 2X and this is 2X. So area will be 4X square. As they're connected in series, whenever they're connected in series, so current in M will be equal to current in N. And according to transport equation, the current is equals to N A QV. And here also N A QV. N is the number of the charge carrier because they are made up of same material, so that will cancel out. What about area of this one? This is X square. Q will cancel out Q. Drift velocity in M. And here area is equals to 4X square. Because one side is 2X, so total 2X into 2X, 4X square. Then this Q can cancel out and drift speed N. Which of the following is the drift speed of in N? We want this is drift speed. So when we simplify, X square will cancel with X square. Or this 4 is multiplied, other side it will be divided. So it will be Vm divided by 4 is equals to Vn. So it means the drift velocity is N is equals to drift velocity in M divided by 4. So for 7, A should be the right answer. The lamp is connected to a power supply. The potential V is switched on. At a time, the graph shows how the current varies in the beginning because the circuit is having a low resistance. So current increases. Then why the current decreases? Because the circuit resistance start to increase. The data logger is used to measure current. Which of the following is the reason of using a data logger for this experiment? So why we are using a data logger here? It is because if we use a stopwatch, we cannot measure a very short time interval. This time interval, using a data logger, we are able to identify the change in the current for this short interval. Otherwise, this will be missed without a data logger. So what is the advantage of a data logger? It can take a reading in a short time interval. That's B is the advantage. Which of the following is numerically equal to work done on the lamp after 0.16 second? So voltage, current and time. Basically, voltage is equals to work done per unit charge. So if we need work done is voltage into charge. So voltage in the question, they already mentioned here for first 0.16 second. So for first 0.16 second, work done is equals to voltage into charge. So how I can find the charge here? Whenever we have a current and time graph, any current and time graph, the area under the graph, we can have any shape of the graph, but the area under the graph will give us the charge, because area is equals to quantity on x-axis multiplied by quantity on y-axis. So when we multiply by the two quantities, we'll get the charge here. So this total area will give us the charge, and we need the work done. So voltage is work done per unit charge, or work done is voltage into charge. So voltage multiplied by charge. How to get the charge? That is area under the graph. So voltage into area under the graph will give us the work done. That's why A is the right answer for this. So if the current and charge graph, current and time graph, the area under the graph will give us the charge. Question 10. The temperature of a negative temperature coefficient thermistor increases. If the temperature increases, resistance will decrease because it is inverse. And if resistance decrease, the current will increase. So current is I is equals to NA/QV. So for a semiconductors, A and Q are constant. Drift will speed whenever, and what is the relation between drift speed and temperature? They are inverse. If temperature increase, the drift speed decreases. So here drift speed is decreasing, but why the current increases? Because the number of the charge carrier increases. So increase the kinetic energy, that's wrong. That will decrease. Increases the lattice vibration. You don't have a lattice vibration here, it's for metal. Increases the number of collision between conducting electron and atom, that is also wrong. That is again for metal. Increases the number of conduction electron, that is true, because as the thermistor temperature increases, more electrons will come out from the bonding. As greater number of charge carrier, the current will increase. And remember, the drift speed and the temperature are inversely proportional. If we increase the temperature, the drift speed will decrease. So for semiconductor, increase in temperature will increase the charge carriers. As a result, more charge carriers, greater conduction of the movement of the charges. So the current will also increase. So this was June 2018.